So now we're going to move ahead to indifference curves. So what exactly are indifference curves? Well, they're going to be represented here on the graph by these green lines. Now, each line represents a particular level of happiness, utility, satisfaction, value, however you want to call it. It's the extra benefit we get with consuming any particular combination of goods. So if we had, say, this many units of good X and this many units of good Y, that's going to put us right here on this indifference curve. Now, I've said here that this indifference curve is going to have a utility value, so U equal to 10. Now, as you increase in indifference curves, you're going to go up in value. So if we went from this indifference curve to the one higher, in this case, we're going to go from a value of 10 to a value of 20. Now, the numbers themselves can be anything. It really just depends on our particular question. So just pay attention to that. But often, it's going to be enough to say what's going to be more value and what's going to be less. So what else can we say about the graph? Well, we can also look at the marginal rate of substitution. So that's going to be this expression. So that's negative times the change in y divided by the change in x. So what exactly does that mean? Well, what we're saying here is that if you change the quantity of x, it's going to tell us how much of y we need to give up in order to end up at the same utility. So let's say here we want to consume one extra unit of good x. Well, that means we're going to have to give up a unit of good y in order to get the same value. So what they're kind of saying here is that x and y are interchangeable. That's to say, if we were to have a little bit less of one and a little bit more of the other, we could potentially be just as good off as we were before. Now, if instead what were to happen, we were to have an increase in our income, then we'd be able to buy more of both goods. And that could be taking us from this indifference curve here to this one up here. We're going to get into those details a little later on. First, before we continue, I want to look at some of the properties of indifference curves. So you'll know them when you see them. The first point is that these indifference curves are negatively sloped. So that's to say they're always going to be decreasing, but they could also be constant or even decreasing here at a slower rate. So that's to say you're going to have kind of this curve shape, or you might even have a straight line here, or you might even have an L, like indifference curves at 90-degree angle. Sorry. Property 2, so the indifference curves are not going to intersect. That's to say the indifference curves are never going to cross at any point. Each indifference curve represents its own value. So if this indifference curve represents a value of 10, then it's going to be the only indifference curve that represents 10. It's going to be impossible for this one or even any other indifference curve to cross this line because it's going to have a value of its own. The third property, indifference curves are convex. So what exactly does that mean? Well, we're going to compare either convexity or concavity. So that's to say the shape of the curve here always in relation to the origin. So convex means it's going to be bowed away. So that's to say it's going to kind of curve outwards like this. Now, if it was concave, it would kind of curve inwards like this. And it's because of these properties here that we're going to get that convexity. So we're going to see later on just how exactly that's important.